Hello everyone, welcome to Tuteetute. In our previous video, we have seen perpendicular polarization and parallel polarization, total internal reflection, all those things we have seen. Now, especially we will concentrate on critical angle and Brewster angle. So these are the angles of incidence only. So when can we say the angle of incidence is critical angle, and when can we say angle of incidence is the Brewster angle? Those things we will see. Okay. So first we will see critical angle. For example, this is the interface. Interface I am taking as XY plane, similar to our previous videos, and z-axis is the normal to the interface. Okay. And obliquely I have incident one electromagnetic wave. Because of the impedance mismatch eta1, eta2, reflected wave is possible and transmitted wave is possible. So in case of total internal reflection, we have studied about how the entire incident wave is reflecting into the same medium 1 without transmitting into medium 2. So whenever we are talking about total internal reflection, there is no question of transmitted signal. Transmitted wave is equal to 0. Okay. For this, what is the condition we have given? From the Snell's law we have taken that one actually. That is beta 1 sin theta I is equal to beta 2 sin theta t. So since there should not be transmitted wave, there is no question of theta t. So sin theta t we have taken greater than 1, so that is not existing. Theta t is not existing. So accordingly, we have taken the condition beta 1 by beta 2 into sin theta I is greater than 1. That is what we have to take. It is actually equal to sin theta t. Sin theta t is greater than 1, so that there is no transmitted wave. Otherwise, we can talk in terms of this one also. So, beta 1 by beta 2 sin theta I is greater than 1. Then we can get a total internal reflection. This is a condition actually for total internal reflection. But we did not specify a single angle of incidence. From that particular angle, this total internal reflection is possible. Like that we did not talk till now. If you observe here, it is greater than. If it is equal symbol, then we can tell one angle we can tell. But it is greater than 1 means many angles are possible here. Okay. Many values of theta I or many angles, many values of theta I are possible for getting total internal reflection. Okay. But what is the starting angle? That is called critical angle. So for what value of theta I, this transmitted theta t, angle of transmission is equal to 90 degrees. Theta t is measured from with respect to this one only, na? So this wave is coming and it is there on the boundary. Then it will be totally reflected into the medium 1. This is possible whenever we are increasing this particular, we are changing this particular theta I. For what value of theta I, this theta t is equal to 90. That means it is entering into this medium 1. Okay, like this, it is entering into medium 1. So for what value of theta I, theta t is equal to 90, thus theta I is equal to critical angle theta c. That is what we need to take. So accordingly, if you substitute these details in this equation, what will happen? Beta 1, I am looking for critical angle. So theta I is equal to theta c. Whenever you are keeping here theta c, then transmitting angle of transmission is equal to 90. That means sin 90 is 1. So what is the theta c formula? Sin inverse of beta 2 by beta 1. This is a critical angle information. Now we will see what is Brewster angle. In case of critical angle that came in the total internal reflection, total wave has been reflected. Brewster angle is opposite to that one. No reflection, only transmission. It gives the information about only transmission, no reflection. Okay, so I am taking again the boundary, that is a xy plane, this is the z axis, this is normal to the boundary. So this is the incident wave, reflected wave, transmitted wave in general case. This is eta 1, eta 2. Why do we get reflection? Because of the impedance mismatch. But here very interesting point is, here theta I we have taken, and this is theta r, and this is theta t. And the interesting point regarding this particular Brewster angle is, we can have total transmission only without any reflection at one particular angle of incidence. So Brewster angle is also related to angle of incidence only. This angle of incidence is equal to, we can tell that is the Brewster angle theta b. For that particular angle, we don't have any reflection, even here impedance mismatch is there. So listen carefully. Whenever impedance mismatch is there, reflection is there. But we can make reflection is equal to 0. We can make reflection is equal to 0 at only one particular angle of incidence, that is called Brewster angle. I am saying total transmission, that means no reflection. That means just make reflection coefficient is equal to 0. Gamma t, gamma perpendicular. If you take perpendicular polarization, what is the reflection coefficient formula? Eta 2 cos theta I minus eta 1 cos theta t by eta 2 cos theta I plus eta 1 cos theta t. Make this gamma perpendicular is equal to 0 for not having the reflections. That means only transmission. At that time, this theta I is equal to theta b. So accordingly, if you substitute, eta 2 cos theta b is equal to eta 1 cos theta t. Like this we can write. Okay, and we can able to further proceed to get the theta b angle. Similarly, gamma parallel is equal to eta 2 cos theta t minus eta 1 cos theta I by eta 2 cos theta t plus eta 1 cos theta I. Here also in the parallel polarization also, for one angle of incidence, that is a Brewster angle. If you incident the wave with the value of the Brewster angle, then these reflections will not be there. At that time we can write this numerator is equal to 0 we will get. So eta 2 cos theta t is equal to eta 1. Because we are applying at Brewster angle, this theta a should be represented with the theta b. Because it is a perpendicular polarization, theta b perpendicular, we have to represent like that. Because it is parallel polarization, theta b parallel. So in this particular perpendicular polarization, you will get one theta b perpendicular by solving that one. And in case of parallel polarization also, another type of Brewster angle you will get. Two different equations you will get. Okay. And how to solve that one, we can able to see. And here theta t also we can written in terms of theta I by using Snell's law. Okay. So in order to get the equations, here I will give just the procedure. You take this is equation 1, this is equation 2. And here Snell's law of refraction, if you take beta 1 sin theta I is equal to beta 2 sin theta t. Just square these two equations. Beta 1 square sin square theta I is equal to beta 2 square sin theta t square. And sin means we can write in terms of cos. So beta 1 square 1 minus cos square theta I, that is equal to beta 2 square, it is 1 minus cos square theta t. Wherever cos theta t is there, you can replace from this particular equation. But theta I means we are working with the Brewster angle concept, so you substitute beta theta b. If it is perpendicular polarization, you take theta b perpendicular. If it is parallel polarization, take theta b parallel. Accordingly, you can substitute in these two equations and you will get the value of are the equation for theta b perpendicular, theta b parallel. And those equations will be like this. Sin square theta b perpendicular is equal to, or you can write for sin also by taking root. Okay. And these are the two equations you will get. So once I will read these two equations. Sin square theta b perpendicular is equal to, that means it is related to perpendicular polarization, 1 minus mu1 epsilon 2 by mu2 epsilon 1 by 1 minus mu1 by mu2 whole square. And in case of sin square theta b parallel, that means related to parallel polarization, 1 minus mu2 epsilon 1 by mu1 epsilon 2 by 1 minus epsilon 1 epsilon 2 square. You need to observe the equations. Just observe the equations and you comment on non-magnetic materials. So if you take non-magnetic materials, what is the meaning of non-magnetic materials? Whatever the material is non-magnetic material, its these permeabilities are exactly equal to free space permeability only. That means mu r1 is equal to mu r2 is equal to 1. Like this we can tell. Okay. Mu1 is equal to mu2, like that also we can tell. So you see now this particular equation related to Brewster angle of the perpendicular polarization. So for the non-magnetic materials, mu1 is equal to mu2. So this value will become 1. 1 minus 1 is 0. Something by 0 is infinity. So sin square theta b perpendicular, you are getting infinity. Can we have sin value greater than 1? No. But here we are getting infinity. That means very large value. So theta b perpendicular is not existing for non-magnetic materials. This is what you need to listen. So once again I will tell what is Brewster angle means. It is an angle of incidence. At that particular angle of incidence, we don't have any reflection. That means completely wave will be transmitted. This concept is available for certain materials. But in case of perpendicular polarization, especially for the non-magnetic materials, this angle is not existing. We cannot make the total reflection is equal to 0 in case of perpendicular polarization, that too for non-magnetic materials. For other materials, it is okay. Okay, we can have this mu1 is different from mu2, so that this denominator cannot be equal to 0 for general materials. But for the non-magnetic materials, here we don't have this theta b. We cannot able to make total reflection is equal to 0, or we cannot able to transmit into the medium 2. Okay, whatever the incident wave is there, completely we cannot able to transmit. That flexibility is not there. But if you see this parallel polarization Brewster angle, in the denominator we have permittivities. So even you are taking for non-magnetic materials, that means even you are taking mu1 is equal to mu2, there is no problem. Here we can able to have angle, Brewster angle we can able to have for complete transmission purpose, or for having the no reflection. Okay, that is what you need to understand. So for non-magnetic materials, theta b perpendicular is not existing, but theta b parallel is existing for non-magnetic materials. That is what you need to understand. Okay, thank you.